Okay, in this video we're going to talk about normal probability distribution, and for this problem John's commute time to work during the week follows the normal probability distribution with a mean time of 26.7 and a standard deviation of 5.1. What is the probability that the commute time for a random selected day will be less than 18 minutes? I always like to draw my normal curve, and your mean always goes in the middle. So our mean is 26.7, and we want to know the probability that the commute time would be less than 18. Well, 5.1, 26.7 minus 5.1 would be 21.6. So 18 is a little bit over one standard deviation away. I'm just going to put it right here. Oh, 18. Sorry. So less than would be to the left. So when we look this up on the table after we change it to z-score, the probability will be exactly what is on the table since it's less than. So first let's do our z. So z is x minus the mean divided by the standard deviation. We know that our x value is 18, our standard deviation is 26.7. Our mean is 26.7. Our standard deviation is 5.1. So when we subtract and divide, we will get negative 1.71. So when you look that up on the table, negative 1.71 would be right here, this 0.0436. So the probability, when we change this to z-score, the mean becomes 0 and the value of 18 becomes negative 1.71. And what that means, it's 1.71 standard deviations to the left of the mean. So the probability that x is less than 18 is the probability that z is less than negative 1.71. So our answer here would be 0.0436. So you may be thinking, well, what if it was greater than? What would happen? So let's look at an example of greater than. So here, John's commute time to work, we're still using the same mean and the same standard deviation, but this time we want it to be more than 30. So our mean is still 26.7. So 30 is going to be a little bit less than one standard deviation to the right. I'm just going to put it here, and we want more than. So whatever we look up in the table is going to be to the left of this. So we're going to have to say 1 minus whatever's in the table. So we know that our z-score is our x value minus our mean divided by our standard deviation. We know that x is 30 and our mean is 26.7 and our standard deviation is 5.1. So if you put that in your calculator, I believe you get 0.65. So you have to, this is in Appendix A in the e-text too. So we have to find the positive numbers. So 0.61 would be 0.65, sorry, would be 0.7422. So that means that the area up to 30, less than 30, would be 0.7422. So I know that my side in 0.7422 would add up to 1. So we have to work backwards here. So first of all, the mean would be 0 now, and our new unit, and this is 0.65. So my value is 0.65 standard deviations to the right. The probability that x is more than 30 and the probability that z is more than 0.65 would equal 1 minus 0.7422. So the probability that a randomly selected day would be more than 30 minutes is 0.2578. And that is how you calculate the z-score and the probability for a normal probability distribution. Let me know if you have any questions.